Hey everybody, Chris here from Dummy Plug Conspiracy. Hey, people are actually watching these videos, so I'm going to keep making them. I wasn't sure what would happen, but my friend Hal told me this would be a good idea, and he was right. People seem to be responding. So today we're going to talk about that critical first order. Because again, I didn't want this to be all about buying stuff, but most people don't have a garage full of resistors and transistors and, cut metalwork and PCBs. You're going to have to buy some stuff. You're going to have to place that critical first order. And it's for me at least, it was one of those things where I had a lot of anxiety about maybe not buying the right stuff, or maybe buying everything except that one thing I needed that would make that first wave of work really rewarding. And I asked a lot of questions and did a lot of research, and this is sort of what I found. So we'll talk about what the minimum entry level is for this, so that what you're going to build is actually going to do something and that you'll stay engaged with the project. And we'll talk about what all these little bits and pieces are, because that was another thing I did, was about to do very wrong until someone kind of hopped in and helped me out and said, well, you also need this, this, and this. And big thank you to Paul Cooper at Soundtronics UK, which again, I'm not trying to promote anybody in particular, but Paul was endlessly patient with me and showed me a lot of things that I might not have figured out on my own. So you're going to probably have to find a person like that. And we'll talk about where to find those people too. So let's jump into it. Here we go, that critical first order. You should probably get familiar with the Modular forums. This is where a lot of people are out there just looking to help all day long, looking at the forums, looking to share knowledge with other people. And some of them definitely want to tell you how smart they are. My advice is to let them. There's a lot to be learned here. There's a ton of support, people who are really, really good at this. And obviously, when you start scrolling around here, right off the bat, you can see, 5U format modules, or look for a particular manufacturer or whatever. But there's just a ton of people out there willing to help you. And researching here ahead of time is great. But coming here when you have problems is a lifesaver. It's probably no problem you're going to run into that one of these people hasn't already had and figured out. And a lot of them have got equipment you don't have, a lot of them have experience you don't have. Take advantage of it, set up an account, use it as much as you can. You'll be glad you did. Also, get familiar with music from outer space. I think it's almost disrespectful to do an analog 5U DIY project without building at least a few of these modules. I mean, this is the stuff. This is the late Ray Wilson poured his life into this, and it was just some of the coolest stuff out there. Lots of great documentation. When you go into the synth DIY section, you'll find any of a number of cool modules or nifty little projects you can do, and the documentation is incredible. He not only goes through a lot of detail about how they actually work, what to expect, all the schematics are there, anything that you might have to refer back to. Because again, remember, the thing about schematics is you might not look at them while you're building or while you're learning what the module does. He's got great sound bites to show you what the module does. But if you have problems, if something doesn't work, then you're going to find yourself looking at schematics maybe more than you ever expected. This tells you how to calibrate things, everything you would need to know. You see some stuff in red, warnings about how some things work. And then the beauty of this is down at the bottom. If I keep going and going and going and going, all the calibration stuff. If you're etching your own PCBs, he's going to actually give you everything you need to know about top side and bottom side. If you're doing two-layer PCBs, you can etch your own. I don't do that, but some people do. Everything about where components are oriented, how the panels look, and you can of course print this if you want to, or you can just sort of use it as a guide. And then all the wiring diagrams are here too, which regardless of whether you do these in 5U panels or something else, the wiring's all going to pretty much stay the same, knowing where things actually connect back to the boards. And then all the way at the bottom, there is your bill of material. Because again, you do not have to buy these parts kits as a kit. you can go source them on your own. You can even find on Mouser and DigiKey and places like that pre-existing bills of material for these projects, and you can go buy the stuff on your own if you want to. But keep in mind, if you do want support, and if you have somebody out there who's willing to help you, then you may want to order that stuff from them. Again, you can't buy a PCB from one guy and a pack of resistors from another guy and expect any one of them to support you if something doesn't work. That's just not how this stuff goes. So if you do want to have somebody on the hook to kind of give you some guidance after the fact, it's a good idea to buy everything you can from that person, because that's really the only way there's an obligation there. So be a little sensitive to that. Another good thing to try to stay organized is to make a spreadsheet of all of the stuff that you intend to buy or that you already bought. You can see in mine everything's highlighted yellow, and that's how I tell myself that I already bought it. But I keep a section for the basics of each module, which would be a panel, a bracket, a PCB, and a component kit. Sometimes I don't buy my components as a kit, but often I do. And then I also have a list for consumables, which is going to be just wire, brackets, connectors, little things like that that you're just going to kind of go through all the time on every synth or every module you build. So keeping track of that stuff, keeping track of what it costs even, because again, if you're ordering it from overseas, that's going to shift when the value of the dollar shifts. I like to keep track of all that stuff, remember how much I spent on it all, just as a means of keeping track of the value of what I built as much as anything. Also, I found it useful in the planning stages and as I was getting near filling my cabinets to know what was going into them and where things were going to be, because a lot of this has to do with physical space and physical location. Just even determining how long your patch cords are going to need to be, you want to know where the outer edges of this thing are and where everything's located. It's convenient to have VCAs close to mixers. It's convenient to have LFOs close to filters. Making this layout for me kind of gave me a planning position, and obviously you don't want to go into too much detail with it, but I sort of decided I wanted filters and oscillators roughly in the middle, and processors at the bottom, and modulators at the top, and the sequencers in the very top row, just because to me that made most sense, but everybody's going to do it differently. But it's a good idea to sketch it out first. Alright, so let's talk about the specific stuff you're going to need. And I'm going to kind of, I just ripped this out of my system. This is my slew generator, you see, with my little custom paint job and everything. And that's of course what these look like on the back. You've got your PCB, your bracket, your wire, all your stuff that you've kind of crammed in there. And you see I'm not a perfectionist when it comes to how I dress wire and stuff. But how do you get to this point after having just bought a bunch of stuff? So let's set this aside. And here's one of my shop bins where I have a project lined up and ready to go. And I'm going to show you what all the pieces and parts are, because these are the things you're going to have to go from this to completion. And it might not be super obvious if you've never done this before. So here we go. First and foremost, I think this is the best place to start. You're going to need a PCB. Right? Like I said, some people etch these at home. I don't. I buy them pre-etched because there's just huge margin for error here, and I don't need the hassle of, wondering whether I screwed something up that far at the beginning of the project. So I don't do these myself, but you buy these pre-etched. These are generally two-sided, and that's where all your components are going to live, and you got to buy this. There's a bunch of places you can buy them. This particular one is a Music from Outer Space project. I did a lot of stuff with synth projects, which is Yves Jusson's designs. And a lot of people have licensed those, and you can buy them a bunch of different places, like SynthCube and Soundtronics and so on. You'll find other ones too. So you're going to have a PCB. Okay. Next, you're going to need components. And again, this particular one, I got all of my components in a little bag, but you see, there's resistors in there, integrated circuits. Those are probably TLO72s, although I can't see right now. My eyesight's not good enough to tell you. Dual inline sockets, potentiometers, I see some capacitors, there's a transistor, there's a couple of switches. There you go. single pole double throw switch. Okay, so that you're going to need. And remember, like I said before, you can buy that as a kit, certainly, if you want to. In some cases, that'll make a lot of sense. But with that, you also generally have published the bill of material, you know, where you can go and source these by yourself just by going on the website and figuring out what you're going to need. None of this stuff's really that exotic. In fact, as you go through this, you're going to see the same, you know, the same integrated circuit chips over and over again, because a lot of this is based on, you know, the same stuff. When you run into one that's really unique, you're almost surprised because you've seen the same one so many times. You know, comparators and amplifiers and op amps and things like that become rather common as you do this. So you're going to have your components, your parts, and that generally does include potentiometers and switches. What it doesn't include is connectors, which we'll get to in a minute. Next thing generally is going to be a bracket, and this is acrylic. I was going to peel the production plastic off just to show you, because you saw the other one was black. Well, this one's black too. It just hasn't been peeled off yet. So these PCBs, they only cost $1 or $2, but that's what's going on back here. That's your bracket, and generally these work for, you know, multiple styles. Sometimes they're ones that are specific to a design, but not always, you know, and obviously this mounts the PCB with some spacers and some nuts and bolts to protect everything going on the back of the PCB, because you don't want anything with wire continuity to touch other stuff in your synth. But it's also because you don't want to mount the PCB directly onto the aluminum, because then you'll have continuity through to the panel, and you don't want that either. Because if something does get disconnected, or if you have a ground fault or something, you don't want it to go and electrify this or touch ground with other ones that are being shared. So obviously you want to decouple those things when you can. And I'll show you that hardware in a second too. So that's your bracket. Not a big expense, but something you're going to need. Next is your panel. Now I get these pre-cut sometimes. I cut my own sometimes too. If you don't have the luxury of a metal workshop, then that might not be an option for you. But these sometimes are offered with an overlay that already has the labeling and everything on it. And that's great. If you want your synth to all be classic black with all the same knobs and have it look like, you know, your typical, you know, Moog or something like that, then by all means go buy that stuff. It's going to look awesome. I didn't want to do that. You guys have seen my synth. It's crazy looking. And again, you know, I do stuff like this. I like doing my own paint. I like choosing my own knobs. So I get these just cut but blank, and then I paint them or do treatments on them or attach stuff to them or whatever, and I label them various ways. You know, this one I labeled with a combination of just you know, Dymo labels and some handwritten stuff. You could do whatever you want. To me, that's what's fun about this. I look forward to doing the panels. As much as I look forward to hearing these things, I look forward to designing the panels. I think that's a lot of fun. So for me, this was the right way to do it. I've never actually bought one of those overlays, but they're pretty easy to come by. Some places already have it etched in. It just depends. People do it differently. But you're going to need that, because that's how this thing actually mounts in your cabinet. We'll talk about cabinets another time. What else? You're going to need hookup wire. This is just your basic, geez, I don't even know, it's 28 gauge probably, I'm guessing, 26 or 28 gauge. Thin hookup wire, and it comes in all these colors. If you're a perfectionist, you can actually color code by function. Or at least you can make ground green, which, you know, for some people that's just visually easier. To me, I don't care that much. I didn't pay much attention to that. Sometimes my grounds are green, but not always. I mean, in my experience, if something's broken and you got to go in there and take stuff apart, you're going to end up tracing that wire manually anyhow. What color it is just doesn't help me that much, so I don't pay much attention to that. And by the way, you see a lot of my wires are twisted. That doesn't electrically do anything. It's just a convenience, because if you've got multiple wires going to the same place, twisting them together keeps things from getting completely rat's nest messed up, which just makes your life harder, so I like to give them a twist. It looks kind of cool too, but that's not why I did it. Also, you see here I've got my power supply tail. This hangs off the end, so one of the other components you're going to need is a piece of power wire. This is a 1.2 amp 3-conductor power cable. You can kind of see in there it's got red, green, and blue. So typically we're going to use red for your positive voltage, blue for your negative voltage, and green for your 0 voltage. That's logical to me. I don't care how anybody else might do it. That's what I've been doing since the beginning. So I keep doing that. Somewhere here, if I can find it, we've also got that power connector. These are kind of like Phoenix block looking. They're not actually by Phoenix, but there's a whole bunch of ways to do this. There's so many different headers you can use. Some people even use headers on the connections for their solder points. You know, I have mine soldered right into the board. Some people do those with headers, which is why they kind of got them lined out like this, so you can easily solder in a header so it's a snap disconnect. Again, I don't see a ton of value in that because taking these apart, I'd only do if something was broken. So I don't really care if it snaps apart or if I got to clip a wire. It just doesn't help me that much. So anyway, there's your power stuff. I'm trying to do this in an organized way, which is difficult to do. I keep Velcro around, like I said. This is your basic, two-side Velcro, so you can just cut it to length. That's for wire management. You probably saw in here I had a wrap of Velcro just to keep the wires in. Because again, the idea is for the wires to not stick out past the edges of the panel, because you don't want them interfering with the one next door to it. Then, your quarter-inch connectors. There's a whole bunch of different ones on the market. I use these. This is actually kind of a knockoff of a Switchcraft part. I have an import version of it, but you can see it's built into this sort of like a box almost. And then you've got your 3 conductors on the back. That's an important thing, by the way. 3 conductors. Why are there 3 conductors? We're only using tip sleeve connectors. It's because that third one is actually a little jumper. There's no way you're going to be able to see that. Well, maybe you can. So there is a way to wire this such that you can cascade from connector to connector by having that continuity touch down and jumper it over to the next one. And there are certain projects where you're going to do that, which are a little bit more advanced. And if you've never dealt with like normaling before, like if you don't know a lot about patch bays, that might seem kind of weird to you. But it's all just wire continuity. It'll make sense when you see it plotted out. The schematic might help. Again, you're going to have to kind of get used to looking at schematics, not so much for the build, but when you have problems. That's when you're going to find yourself looking at schematics. So I had 4 of those in this particular build. I had a wire tie in here because I like to do my power. That's got a wire tie. And I do that so that this thing isn't flopping around. I don't necessarily care about wire ties for everything else. I use Velcro for everything else. And what else? I go and source my own knobs. This is just one example. I've got about 1,000 different kinds of knobs in the garage, but just any kind of knob you want. You're going to have to buy these somewhere though, otherwise your potentiometers are just going to be that split post. So get comfortable with ordering knobs. I mean, Amazon, eBay, whatever. Everybody offers some kind of knobs with their kits too. I didn't want them to all be the same, so I went and sourced my own. And everything else in here is kind of little stuff. Here are the brackets that hold the, remember we were talking about what this guy's for, right? You're going to put your PCB on here, and then this bracket is going to hold that onto the panel. Gotta buy those. If you don't buy those, you can't connect them. Actually, I should mention these too. This is what's called a bootlace ferrule. See that? Bootlace ferrules are for power cables to prevent loose strands of conductor from touching down on the one next to it. So you can't see, actually you can kind of see. See how I put the bootlace ferrules on the end of my power cables? And then I stuck them into the connector. And I did that so there was no chance whatsoever that a loose strand, because this is stranded wire, you never want a loose strand touching the thing next to it. That'll cause all kinds of problems, as you can imagine. Bootlace ferrules are a good way to handle that. You can crimp these on, but I've taken to soldering them. So I stick the wire in the back and I just put a tiny little drop of solder in the end, and that holds everything together pretty nicely. Again, all your basic nuts and bolts. And standoffs. Might not seem important, but these little silicone standoffs, I use these for my power distro panels, but look at that, I also use them in here. Because you're going to need space, because you see, all those little lumps of solder, it's not possible to sandwich this up directly. You have to have a standoff in there to give it a little bit of space. So get comfortable with things like that. And, again, a lot of this stuff you can get at a hardware store, but I mean, if you're going to be ordering it from somebody anyway, especially if you're trying to conform to their build process, it's reasonable that you should be using the same stuff that they're using. Because if you don't, you're just going to find yourself, holes aren't going to be the right size, things aren't going to fit. You don't want that. That's a hassle. So this is just sort of everything I could think of that goes into building one of these, without going into any detail about designing panels, which we'll talk about later, and we won't talk about cabinets until later either. But this is a pretty good overview of the pieces and parts that you're going to need to build a finished product. The one thing I didn't mention here, and I guess I'll talk about this again at some point anyway, is having a MIDI to CV converter is fairly important if you're going to try and play this thing from a traditional, MIDI keyboard. Obviously, there's some people that do voltage controlled keyboards that are more, traditionally modular products, but in reality, those aren't terribly useful in a modern digital studio. So the one thing I couldn't find a kit to build was that. I couldn't find a MIDI to CV kit because I sort of made a deal with myself that I was going to build everything. I wasn't going to use stuff that I couldn't build myself. Nobody really made one that was what I wanted. There were some that were kind of close, but most of them weren't really kits. Actually, Soundtronics makes one, but theirs was using 3.5 millimeter instead of 5-pin DIN connectors, and just wasn't quite what I was after. I think it was Eurorack, and I would have had to adapt it, and just wasn't for me. So I ended up buying one from Modular that's been great. Nothing wrong with it. But again, the goal is to buy the stuff that you need to make something that sounds like a synthesizer. And the one thing that was missing for me was that. I had to go off and buy that pre-built. So anyhow, once it was all done though, what I believe the minimum stuff is that you should buy: an oscillator, a voltage controlled amplifier, and a MIDI to CV converter is enough to get you to a point where you can hear your synth do something when you press a key. And here's a video of my first time making that work, when all I really had was those three things, and it was great. It was triumphant. I was pretty excited. It was awesome to see it actually behave like a synth. Now here we are, all hooked up through this MIDI converter. Trimmed everything and tuned it, and we got a real live working synth here. Anyway, having said all that, if you were going to throw some other things on that order, for fun, that are going to keep you interested in the project and make it be even cooler and more interesting, get yourself a filter and get yourself an LFO. So again, I don't want to define all those terms because I think if you've come this far, you probably roughly know what those things are, but I'll do it here anyway. Okay, oscillator makes the noise, pitches. The MIDI to CV converter is going to send pitch commands to the oscillator and on-off commands to the VCA. The VCA stands for voltage controlled amplifier, and that's what makes things turn on or turn off. Otherwise, you'll just hear it all the time because it'll always be running. An LFO is a low frequency oscillator that makes things do warbly effects by applying waveforms to either filters or oscillators. And a filter takes the full frequency spectrum and carves out sections of it so you can get those kind of wah effects and stuff. I probably didn't need to tell you that. But anyway, if you're going to try and have fun with this, if you're going to try and get something that sounds like a synth, if you buy those 5 things or whatever, 6 things, you'll have something that sounds like a synth and you can build from there. I want that first order for you at the end to actually be something usable, because that's what's going to keep you involved and keep you wanting to go to the next step with it. So kind of plan for that. Otherwise, you're going to feel like you built a bunch of stuff and you're still nowhere near there, and that can be frustrating. Okay, we're going to talk about power supplies next. We'll see how that goes. Thanks for sticking with me.